Hey there, it's Mrs. Marquette. Today we're talking about the last way to solve quadratic equations. So we've done factoring, we've done completing the square, we've done square root method. The method that we're going to use today is actually our surefire, this will work on any quadratic equation kind of formula. So it says the quadratic formula is another method for solving quadratic equations. It can be used on any quadratic equation, even equations that can't be factored. So if I zoom in on this quadratic formula, we notice that we have ax squared plus bx plus c. We know it's quadratic because of that squared. This a is a number, the b is a number, and a c is a number. That is important because my solutions are x equals the opposite of b, being a number, plus or minus, the square root of b squared minus 4ac all over 2a. So when I solve using the quadratic formula, I've got to check a couple things. First of all, am I in this form, ax squared plus bx plus c equals 0? So I've got to be in order from x squared, then x on my number, and then I have to have the other side set equal to 0. It doesn't matter which side is which, but I have to have that form. Then I can figure out what a, b, and c are and kind of go to town. So I have 0 equals x squared minus 9x plus 8. If I find a, b, and c, remember those are just the numbers. I am in order, x squared, x, and then constant. My other side is 0. So a is 1, b is negative 9, and c is 8. So here's my quadratic formula. And I can just plug in a, b, and c. So I go the opposite of b, since b is negative 9, the opposite of b is positive 9, plus or minus the square root of b squared. Negative 9 squared is 81, minus 4, times a, which is 1, times c, which is 8, all over 2 times a, which is 1. Now here's the order that I'm going to plug stuff into my calculator. I'm going to put everything that is under that radical first. So I'm literally going to type into my calculator 81 minus 4 times 1 times 8, which is 49. So I get x equals 9 plus or minus the square root of 49 over 2. Now we actually know what the square root of 49 is, and if you don't, you can plug it into your calculator. But we know that it's 7, so I get x equals 9 plus or minus 7 all over 2. This is really two equations. This is the equation x equals 9 plus 7 divided by 2, and x equals 9 minus 7 divided by 2. I plug in, or I think about what that numerator is, so 9 plus 7 is 16, divided by 2 is 8, and then I go 9 minus 7 is 2, divided by 2 is 1. So my two answers are x equals 8 and 1. Number 2, very similar. We're already in order. We've got a 0 on one side, so my a is 2, b is negative 17, and c is 21. So I'm just going to plug everything in. So I'll do that. So when I plug in a, b, and c, here's what I get. 289 comes from negative 17 squared. And remember that I'm first going to plug in everything under that square root. So I get x equals 17 plus or minus the square root of 121. Notice I haven't taken a square root yet at this point. We'll see why that is in the next couple problems. And then I divide by 4, because 2 times 2 is 4. We know, again, what the square root of 121 is. So I get 17 plus or minus 11 divided by 4. And you can actually just do these two problems at the same time. So 17 plus 11, and then divide by 4 is 7. And then 17 minus 11, and divide by 4 is 1.5, or 3/2. So those are your two answers. So I'm again going to do this first step. So if you want to pause the video, do the first step, and then we'll kind of come back together. So here's what I get just for plugging everything in. 4 plus or minus the square root of 16 minus 4 times 1 times 13 all over 2 times 1. And I plug this whole piece into my calculator. When I do that, I get 4 plus or minus the square root of negative 36 all over 2. Okay, this is why we don't plug it into our calculator under the square root right away, because sometimes we're going to have a negative. And we know that if I plug in a square root of a negative into my calculator, I'm going to get an error. But we also know that this is just x equals 4 plus or minus. If there wasn't a negative, the square root of 36 is actually 6. And the negative under the square root, we just tag it with an I. All over 2. So now my two answers are x equals 2 plus or minus 3i. What I did there is I took each piece and divided it by 2 because it's all divided by 2a. If I wanted to split this up, I could say 2 plus 3i, 2 minus 3i, but since they're not like terms, I can actually leave it as 2 plus or minus 3i. Starting with number 4, we've got to do a little bit of work before we actually solve using quadratic formula. So I'm going to add 10 to both sides, specifically because I need one side to equal 0, and then I'll need an a b, and a c. So now I'm in the form that I need. A is 1, b is -6, c is 10, and we can go to town on quadratic formula. So again, I'm going to plug in. You guys do the same. All right, so we've plugged in. We have everything under the square root becomes plus or minus the square root of -4, 36 minus 40, all over 2. We would say that the square root of 4 was 2, but since there's a negative, this is 6 plus or minus 2i divided by 2. So my final answer will be x equals 3 plus or minus 1i, or just I. That's again because this is all divided by 2. So I take 6 divided by 2 and 2 divided by 2. Number 5, when I get one side equal to 0, I'm really picking like what's the easiest side to set equal to 0. So since there's only one term on the right side, that's why I'm going to subtract 6 from both sides. I want to keep it in order, so x squared and then the x term and then the constant equals 0. And I can start finding my a, my b, and my c. So I'll get x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then I can simplify what's under the radical. When I do that, I get x equals 6 plus or minus the square root of 0 all over 2. The thing about this problem is the square root of 0 is actually 0. So I can get rid of that square root. And I have 6 plus 0 divided by 2. 6 plus 0 is 6, divided by 2 is 3. And then 6 minus 0 divided by 2 is also 3. So 6 minus 0 is 0 divided by 3. So this is a repeat answer. So instead of writing down 3 and another 3, I'm actually just going to write down one answer. But we know that we actually were able to find that repeated root, or that repeated 0 answer. For number 6, I still want one side to equal 0, so I subtract 16k squared from both sides. And I'm going to get 4k squared plus 24, that should be a k, plus 5 equals 0. And then find your a, b, and c, plug everything in. Pause the video and do that. So when I plug everything in, I get 576 minus 4 times 4 times 5 under the square root. Plug that into your calculator. I get x equals -24. Plus or minus the square root of 496 all over 8. Now this is a tougher one because I don't actually know the square root of 46. So if I plug that into my calculator, we find that the square root of 496 is actually 22.271 divided by 8. Now, the thing that we have to do when we plug this into our calculator is we have to plug in the whole numerator, hit enter, and then divide by 8. So I'm going to say -24 plus 22.271 is equal to negative 19.729. Divide that by 8, and I get my first answer is x equals negative 2.466. My second answer is going to be negative 24 minus 22.271, which is negative 46.271, divided by 8 is negative 5.784. So when you have a square root that you don't know the perfect square to, so in this case, the square root of 496 was a decimal, you can still do the problem, but just make sure you really do the whole numerator first, hit enter on your calculator, then divide. I'm going to have you guys pause the video here. I'm going to write the answers for 7, 8, and 9, and then have you check your work. So here are those 3 answers. If you look at number 7, we get a negative 111 under the radical. I know that that negative is going to become an I, but I can also see that negative 9 plus or minus rad 11, no matter what that decimal is not going to be a like term. So I can actually leave that as rad 11I. But if you had plugged that into your calculator and gotten 10.536, and that should be 111, 10.536I, that would also be fine with me. Number 8, I get x is 3 plus or minus the square root of 7i all over 2. If you had gotten 3 plus or minus 2.646i divided by 2, that would also be fine. And then for 9, we get negative 0.375 and negative 1.5. That's because what's under the radical actually is 81, so we know that to be 9. So we can plug in negative 15 plus 9 divided by 16 and negative 15 minus 9 divided by 16. So all of these problems really are just going to take practice plugging into your calculator, really getting comfortable with those keystrokes. So if you were just watching me and not plugging any of this into your calculator, you need to go and do all of these problems because that's going to be really what makes this click for you. We have to talk about one more thing called the discriminant, and discriminant is specifically the number that is under the radical. So that first step that we did every time, b squared minus 4ac, we found to make a big difference because in that first problem, what was under the radical ended up being 49, so we could simplify, and we got 2 answers, 8 and 1. But then later, when we had the discriminant, what was under the radical, being 0, 6 plus 0 and 6 minus 0 gave us a double answer, or the same answer twice. And then finally, when we had a negative under the radical, like here we had negative 4, we actually had an I in our answer. So we still had 2 answers, but they were both imaginary. So those are kind of the 3 situations we're going to get with discriminants. If we just look at what's under the radical, if b squared minus 4ac is positive, we're going to have 2 real solutions because we have a positive number under the radical. So plus or minus a positive number is what that says. We'll give 2 real solutions. Okay, so that's what we saw like in number 1. But if b squared minus 4ac is equal to 0, then we get 1 real solution. That's because plus or minus the square root of 0, or plus or minus 0, is going to give you repeat answers. So whatever the first solution is, the second solution is going to match it. It's going to be exactly the same. And then finally, if we have b squared minus 4ac is less than 0, or what's under the radical is negative, we're going to have 2 imaginary solutions. That's because plus or minus the square root of a negative number, I'll still have 2 answers, but they're going to have I in it. So I'm going to put will have I part. So there will be questions that only ask you to state the value of the discriminant and determine the number and type for each solution. So that's actually going to be a little faster. We still have to be in the same form, so ax squared plus bx plus c equals 0, but then we'll be able to just find b squared minus 4ac. So looking at number 1, I've got a is 12, b is 5, and c is negative 4. We should be pretty fast at that by now. And then what's under the square root is always b squared minus 4ac, or in this case, 5 squared is 25, minus 4 times 12 times negative 4. Plug that in your calculator. And you get 217. So the discriminant is 217. Since that's positive, we're going to have a positive number under the square root. So we're going to have 2 real solutions.